students. So I will talk about the different important organic reactions and reagents. So I have already told you in previous video 5 important chemical reaction. Now the 6 is like this 6. So sometimes ask you very important, how can you show ethyne, or can say alkyne has acidic hydrogen, or we can say substitution or we can say test for ethyne, or we can say difference in between ethyne and ethane. So many questions are asked you in these questions. So how can you show ethyne has acidic hydrogen? Sometimes ask you what do you mean by substitution reaction. Sometimes ask you test for ethyne, or sometimes ask you difference in between ethyne and ethane. So all have same answers. So never confuse. Yes. So what do you see? First examples. When ethyne is reacted with sodium metal, we get disodium acetylide compound and hydrogen gas by substitution reaction. Yes. So when you see, when ethyne means carbon-carbon triple bond is reacted with sodium metal, we get disodium acetylide compound and hydrogen gas. What type of reaction over here? Substitution reaction. So look at over here. So in this case, so what do you say? Ethyne. So when that is treated with sodium, so at first what you get? C Na, and what you see? Yeah, better to write 2 sodium atom. So what you get? Sodium positive charge, minus charge. That is positive charge, and what you get? Hydrogen gas. So that is known as disodium acetylide. Acetylide compound. So in this reaction, what do we see? This sodium substitute displaces acidic hydrogen from ethyne, and what you get? Hydrogen gas. So when we talk similar to when zinc is treated with dilute HCl, so what you get? Zinc chloride plus H2. So what happens over here? So this zinc replaces what you see, this H from H2 hydrochloric acid, and what you get? Zinc chloride plus H2. So in this case also what do we see? Sodium substitute or displace the acidic hydrogen from ethane, and what to get? Disodium acetylide compound and hydrogen gas. So always keep in mind where there is evolution of hydrogen gas with metal. So what you get? It has acidic in nature. So in this case sodium metal reacts with this ethane, and what you get? Disodium acetylide compound plus hydrogen gas. So always keep in mind when there is evolution of hydrogen with metal. So in this case what you see? This zinc react with dilute HCl, and what you get? Zinc chloride plus H2. So in this case also HCl shows acidic hydrogen. I think you have clear what is the acidic hydrogen. Yes, first example. Second one is B. When ethane gas is passed through ammonical solution of silver nitrate, we get white precipitate of silver acetylide by substitution reaction. What type of reaction over here? Substitution reaction. So look at over here. So what you see that ethane, that is ethane, that is treated with ammonical solution of, what is ammonical solution means? Made in ammonia solution. So what we see over here? So both H, because it has acidic hydrogens, so both H are substituted by silver. So what we have? C double bond, triple bond, what we see? Ag, what you see? Ag. So both H acidic hydrogen is substituted by Ag, and what type of PPT we get? White, that is also known as silver acetylide, plus side product is ammonium nitrate plus what you get? Water. Yes. So that is ethane, and I have also told you that this reaction is also used for the what is the difference in between the ethane and ethene. So that is ethane. So what you have? That is the ethene. Yes. Ethene, when this is treated with silver nitrate, that is the solution, plus ammonium, same reagent, no reaction. No reaction. What do you see? In first case there is a reaction. Why? Because it has acidic hydrogen. But in second case there is no reaction. Why? Because it has no acidic reaction. Because it has no acidic. See, if you ask in examination, so how can you differentiate in between the ethane and ethene? Then you can write this reaction. It's very, very important. Yes. So in ethane case, what you get? White PPT of silver acetylide. But in ethene gas, there is no reaction. Why? question arises why? Because it has no acidic hydrogen. Yes, first, second, now third one. See, when ethane gas is passed through ammonical solution of cuprous chloride, we get red precipitate of cuprous acetylide compound by substitution reaction. So look at over here, C triple bond H, that is what is ethane. So when that is treated with cuprous chloride, also C over here. So generally when same, generally you cancel it, but in this case we cannot cancel out. Why? Because when you talk about the one molecule of cuprous chloride, in all cases, what we see? One molecule of cuprous chloride contains 2 atoms of copper and 2 atoms of chlorine. So never cancel this one. So ammonical solution, ammonium hydroxide. So again what we see, that acidic hydrogen, that is ethane. So it has acidic hydrogen gas, so that is substituted by what we say, copper. What type of PPT? Red PPT. What the name of this compound? Cuprous acetylide plus what you get? Cuprous chloride, sorry. What you get? Ammonium plus H2O. So what you see, how many chlorine? 2. So what we have? 2 ammonium, 2 H2O. Yes. But when that is ethane plus cuprous chloride plus ammonium hydroxide solution, so no reaction. Why? Because it has no acidic hydrogen. Yes. So if you ask difference between the ethane and ethene, then you can give what's B and C, both are important for you. Sometimes ask you in what happens, sometimes ask you to write down the difference in between what is ethane and ethene. Sometimes ask you write the test for ethane. If you are asked in examination, write the test for ethane, then you have to give this language and this reaction only. Not necessary to give this reaction. This reaction is only given when difference of what is ethane and ethene gas is asked in the examination. So always be alert, be sincere. So sometimes this question is substitution reaction or acidic hydrogen ask you in 2 mark. In 2 mark, then we have to give only the example with sodium. Sometimes ask you 5 marks. Write down the acidic nature of the what's ethane. Then we have to give all the 3 example. Yes. Sometimes ask you write down the difference between the ethane and ethene. So we have to give only 1 example over here. Yes. Like ammonium chloride, ammonium solution of what is Q plus chloride. Next one is what you see, ammonium solution of silver. Right. It's very, very important. Generally asked in examination. So in examination, this question is asked. It's very, very important. Yes. So that is about how can you say ethane has acidic hydrogen and what are the main differences between the ethane and ethene. Next one is what to say 7. What to say Lindlar, name of the chemist, Lindlar's catalyst. So at first ask you what is Lindlar catalyst. Question is what is Lindlar? Lindlar's name of the chemist, Lindlar catalyst. Give its application. Give its application. So at first we have to know what is Lindlar catalyst. Lindlar's catalyst. So it is a mixture. It is a mixture of palladium metal, barium sulfate, in presence of what to say, in presence of maybe ethyl alcohol, maybe presence of quinoline, that is the solvent, organic solvent. Yes, so it is the mixture of palladium metal and barium sulfate in presence of what is ethyl alcohol, or we can say what's the presence of ethyl alcohol, or what's the quinoline solvent. So what the use of this one? So you have clear what is Lindlar catalyst. Use or we can say application of Lindlar catalyst. It is used to convert ethane compound into ethene gas. It means it is selective reagent to convert ethane to ethanes. It's a very selective reaction. So generally used in research work. When you synthesize any organic compound, at that time you have to use this what you see Lindlar catalyst. Yes. So what you see over here, carbon-carbon triple bond. Yes. That is known as ethane. So that H come from the what you say Lindlar catalyst. So what is a partial partial reaction over here. So what we have? H2, so what we get over here? C ethene. Partial hydrogenation, we can say. Partial hydrogenation. And that compound not convert into the what is the single molecule. So we may ask question. So convert ethyne to ethene. So you have to use this Lindner catalyst. It's very, very important. So I think we have clear what are the Lindner catalyst, what is the use of for application of what you see Lindner catalyst. Next one is 8. What's the Grignard's reagent? What is? Question is like this. What is Grignard reagent? What is the use of Grignard's name of chemist? Why Grignard's reagent is not prepared in moist condition? Yes, so generally ask you related questions. It's very important for you. So what do you see over here? So at first we have to know what is Grignard's reagent. So Grignard's reagent is Grignard's name of the chemist, Grignard's reagent. When alkyl halide is reacted with magnesium metal in presence of dry ether, we get alkyl magnesium halide, which is known as Grignard's reagent. Yes. So when alkyl halide is what you see reacted with magnesium metal in presence of dry ether, always never what's the moist ether. So always in presence of dry ether. So reaction is like this. General reaction, So look at over here. So when alkyl halide REX, that is known as alkyl halide, when heated with magnesium in presence of dry ether, never heated. What we have? MgXR, that is known as alkyl magnesium halide compound. R means you know, X means maybe chlorine, maybe bromine, maybe iodine. Yes. So what do you see over here? So we can keep any R over here. So maybe what you see, CH3Br plus, that is known as bromo methane. When heated with dry ether, so what do you get? Mg Br CH3. So what's the name of this compound? Methyl magnesium bromide, and that is also known as Grignard's reagent. So you have clear what are the Grignard reagents. Yes. So I have told you one question over here. Why what you see Grignard agent is not prepared in moist condition. So look at over here. So when suppose we take simple example like magnesium Br CH3, when hydrolyzed moist condition we can say. So what you see, hydrolysis takes place, and what do you get? H plus OH minus, always formation of electrophile and nucleophile. So what we have? So that CH3 react with this H plus. So what we have? So what we have? CH3H, that is methane. Now we can say alkane. Yes, plus magnesium Br was the Br, that is OH, that is known as magnesium hydroxy bromide. I think you have clear why it is not prepared in moist conditions. So what do you see over here? So water after decomposition, what we get? H plus electrophile, OH nucleophile. So that methyl group react with this H plus. So what we have? Alkane. CH3H means what do you see? Methane. We can write over here, that is methane. Yes. If what you see CH3, what you see ethyl, so what do we have? Ethane. If suppose this is propyl, what do we have? Propane. So that is what you see application of Grignard agents very, very fast. So I will talk in later lecture. So we have cleared what are the Grignard agent and why it is not prepared in moist conditions. So that is the answer of this question. Yes. So after hydrolysis, what we get? Alkane. So we can never prepare what we see? Grignard agent in presence of moisture. Yes. Yes. Next one is some water pen. So what you see, next question is, when aluminum carbide is reacted with water, we get aluminum hydroxide and methane gas. So what we see? We get aluminum carbide. So what the reaction? That is aluminum carbide, when that is treated with water, so what you see? We get aluminum hydroxide plus methane gas. So when you balance, what do you see? At first we have to metal was 4. So what do you see? 4. Then what do you see? Non-metal 3 carbons. What do you see? 3 carbon over here. So how many? What do you see? L 4 3s are 12. 3 4s are 12. So obviously 24 means 12 H2O. Yes, that is. So very 12 H2O. So that is aluminum carbide, Al4C3. Likewise, when calcium carbide is very similar to each other, is treated with water, we get acetylene gas and calcium hydroxide, like so reaction is like this, CaC2. So keep in mind CaC triple bond. So never write what you see 4 carbide. Generally balance of carbide is 4. So never apply over here. So this is the structure of calcium carbide. That is calcium carbide and treated with water. So what you get? Calcium hydroxide plus C2H2, that is ethine, you know. So at first we have to calcium 1. How many carbon over here? 2. How many carbon over here? 2. Now next one, how many oxygen? 2. In this case 2. So what we have to do? We have to multiply over 2 there. So 2H2O, 2H2O, what do you see? C2H2, that is balanced chemical equation. Yes, so these all reaction what I have taught you. It's very, very important for examination view or purpose, you can say. So I think you must practice in your practice and write down all the reactions, all the what you see reactions nicely. I think you can write these all reactions correctly. So these all are very, very important for what you see examination view. So what you see, thank you for visit this interesting what you see video. Rest is okay. So also request you to subscribe all this and what you see convey to all or your what you see friends, classmates, relatives. Yes, I think that is okay.